Good morning, student. In last lecture, we have seen the linear Diophantine equation. We know that the general form of the linear Diophantine equation is ax plus by is equal to c. In this equation, the coefficient a and b are integer. Also, the right hand side c is an integer. The Diophantine equation ax plus by is equal to c has a solution if and only if the greatest common divisor d of the coefficients a and b divides the right hand side c. Once the given Diophantine equation has one solution, suppose x0 and y0, then using this we can find all solution of the linear Diophantine equation. We have seen as a theorem, if x0 and y0 is one particular solution, then all solutions are given by x is equal to x0 plus b upon d into t, and y is equals to y0 minus a upon d into t. Using this formula, today we shall solve the problem on linear Diophantine equation. Consider the problem. Determine all solutions in the integers of the Diophantine equation 56x plus 72y is equals to 14. Now, if we compare with a general form of the linear Diophantine equation ax plus by is equals to c, here we observe that a is equals to 56, b is equals to 72 and c is equals to 40. To find its all solution, at first we shall see that the given Diophantine equation is solvable or not. That means it has solution or not. And it has a solution if greatest common divisor of this coefficient 56 and 72 divides the 40. For that purpose, at first we shall find greatest common divisor d of coefficient 50 and 72. We suppose that d is the greatest common divisor of 56 and 72. To find the value of d, we apply Euclidean algorithm. That means a repeated application of division algorithm. To apply the division algorithm, here we have to find the greatest common divisor of 56 and 72. Here 72 is bigger than 56. We divide 72 by 56, and by Euclidean algorithm we can observe that we get 72 is equals to 1 into 56 plus 16. Then next step is, here the remainder is 16 and divisor is 56. We have to divide this divisor by remainder 16 and apply the division algorithm again. After dividing 56 by 16, we observe that 56 can be written as 3 into 16 plus 8. Okay, again the remainder is 8 and divisor is 16 in this equation. Then we have to divide this 16 by 8. After dividing 16 by 8, we can observe that by division algorithm we have 16 is equals to 2 into 8 plus 0. In this last equation, the remainder is 0, means our application of division algorithm repeatedly, this process is stopped here because the remainder is 0. And by Euclidean algorithm, we know that the last non-zero remainder, here last non-zero remainder is 8, and therefore by Euclidean algorithm last non-zero remainder is a greatest common divisor, and therefore the value of d is equals to 8, which is a greatest common divisor of 56 and 72. Means we get the value of D is 8 and here C is a 40. And we know that 40 is divisible by 8. Means 8 divides 40. 8 divides 40 means D divides C. And as D divides C, the given Diophantine equation 56x plus 72y is equals to 14 has a solution. Because greatest common divisor 8 of 56 and 72 divides the 40. Now, once it has a solution, we shall find one particular solution which is denoted by x0 and y0. Once we know the particular solution x0 and y0, we can obtain all solutions by using the formula. Now this greatest common divisor D can be expressed in the form of ax plus by. D is equals to ax plus by. Here we shall find the values of x and y. For that purpose, the last non-zero remainder here 8, this can be written from this equation. It can be written as 8 equal to 56 minus 3 into 16. Transfer this 3 into 16 on left side and we get 8 is equal to 56 minus 3 into 16. Then this 56 can be done as 1 into 56 minus 3 into 16. But 16 can be written from this equation as 72 minus 1 into 56. Okay. And then this 56 can be done as 1 into 56. Here multiply by minus 3 to this bracket. You will get minus 3 into 72 plus this minus will become plus 3 into 56. This 1 into 56 and 3 into 56 take their sum, it will become 4 into 56, and this minus 3 into 72 as it is means we get yet 8 is equals to 4 into 56 minus 3 into 72. And okay, 8 into 56, this can be written as 8 into 56 multiplied by 4 plus 72 into minus 3. Now here you can observe that right side of the given Diophantine equation is 40. But in our equation it is a 8. To obtain it as a 40, we shall multiply throughout by 5. After multiplying by 5, 8 into 5 it will become 40. Okay, and this 56 into, in bracket there is a 4. 4 into 5 this will become 20 plus 72 into minus 3. And this minus 3 into 5 it will become minus 15. Now finally we shall get equation 40 is equals to 56 into 20 plus 72 into minus 5. If we compare this with the general form of the linear Diophantine equation, ax plus by is equals to c. Here this 20 is a value of x, that means our solution x0 is equals to 20. Value of y is minus 15. We denote this as our first solution, y0 is equals to minus 15. That means we shall obtain x0 is equal to 20, y0 is equals to minus 15 is one solution of the given Diophantine equation. We know the formula that all other solutions are given by x is equal to x0 plus b upon d into t and y is equal to y0 minus a upon d into t, where t is the variable which is any integer. Okay. Now x0 is 20, put that value here, x0 is 20 dv upon d. Our equation is this: 56x plus 72y means b is 72, a is 56, and therefore here putting the value of b divided by d, that is 72 by 8, and x0 is 20 into t. Similarly, y0 is minus 15, substitute here, and a is a 56 and d is a 8. Therefore, this will become y is equal to minus 15 minus 56 upon 8 into t. This 72 divided by 8 is a 9 and 56 divided by 8 is a 7. Therefore, this equation becomes x is equal to 20 plus 90 and y is equals to minus 15 minus 70, which gives the all required solution. That means there are infinite number of solution in the integers, because here t is any integer, means x is equals to 20 plus 90, y is equals to minus 15 minus 70 are the required solutions of the given Diophantine equation. Okay, student, this is a very simple procedure. Those students which are able to find the greatest common divisor of given two integer by using Euclidean algorithm, and then by reversing the values and putting the values of remainder one by one, and to obtain the value of x and y, and here multiply the proper appropriate integer so that the right hand side of the Diophantine equation is same as that of the left hand side of this equation obtained by using Euclidean algorithm. And using this you can find the particular solution or one solution x0 and y0 and put these values in this formula. You will get the required solution. This is a very simple procedure. Only the part is a calculating part which you have to do here. Today we shall stop with only one example, because with this example we shall complete our article, the Diophantine equation. Remaining problem is similar. For example, determine all solution of the given Diophantine equation. That Diophantine equation is 24 x plus 138y is equals to 18. By similar manner you can try to solve this Diophantine equation also. Here you have to remember that, or you can note down that the greatest common divisor of coefficient 24 and 138 after by using Euclidean algorithm, which you should get this as a 6. Listen again, you have to note that greatest common divisor of 24 and 138 will be equal to 6, and 6 divides 18. Therefore this Diophantine equation has solution. Then apply the Euclidean algorithm, find the values of x0, y0. Again note that you should get the values of x0, y0 as 18 and minus 3. That means x0 is 18 and y0 is minus 3. Then substitute these values in our required formula, simplify. Finally you should get the solution as y is equals to, note down, y is equals to minus 3 minus 4t. Try to solve and compare the solution. I am telling that you should get the greatest common divisor of 24 and 138 is equals to 6. Values of x0 is equal to 18. Values of y0 is minus 3. And final solution is x is equals to 18 plus 23t and y is equals to minus 3 minus 4t. Try to solve this. Okay, with this problem we shall stop. Also remember that we have completed our article Diophantine equation. Thank you.